Hello. we
Yes,
have
sir.
we have already
Yes,
discussed
sir.
modulus of a complex number and conjugate of a complex number. How do we find conjugate of a complex number? How do we find modulus of a complex number? So for the sake of revision, let's just try to find conjugate of couple of complex numbers. Then we'll find modulus of couple of complex numbers. And today itself, we'll discuss how to divide one complex number by another complex number, how to find the reciprocal of a complex number, and all that. Okay. Okay, so let me just give you a complex number z, 1 plus 2i, and I want you to let z1 is equal to 1 plus 2i, and I want you to find its conjugate. Well, what will it conjugate be?
So 1 minus 2i.
1 minus 2i, right? You remember I told you, while you are trying to find the conjugate of a complex number, what do? You keep the real part as it is. Don't touch the real part. Don't touch the real part. Simply reverse the sign of the imaginary part. Simply reverse the sign of the imaginary part. Here the imaginary part is 2. In its conjugate, the imaginary part will be minus 2. Real part of the complex number and its conjugate must be the same. Only the imaginary part will have opposite signs. That's it, right? Got it? So suppose I give you another complex number z2. Hello, get it or not?
Yes,
1
sir.
Yes, sir.
minus 3i, minus 1 minus 3i suppose, and I want you to find its conjugate. So don't touch its real part, same. Just
So
reverse this.
minus 1 plus 3i.
Yes, plus 3i. Just reverse the sign of the imaginary part. You get my point so far? Clear?
Yes, sir.
Okay.
Yes, sir.
Okay, take the screenshot. Done. Okay. Well, one more is left. Yes. Suppose I give you another complex number z3. Suppose 2. Well, 2 is what? 2 is a purely real complex number, right? Its imaginary part is equal to 0. Every real number is a purely real complex number. You can write 2 as what? 2 plus 0i. So it is a complex number, that to a purely real complex number. Every real number is called a purely real complex number. Why is that? Because the imaginary part is 0. No imaginary part is there. That is why it is called a purely real complex number. So this is a complex number and I want you to find its conjugate. Well, what will be its conjugate? Anybody? Come on, give me a quick answer. Yes?
So 2.
Same 2, right? Because while you are trying to find the conjugate, you will not touch the real part. The real part will not be touched. And here the real part is 2. You are not going to touch it. Keep it as it is. Simply reverse the sign of the imaginary part. And here the imaginary part is 0. And if you reverse the sign of 0, it will be minus 0. Minus 0 is same 0. So 2, its conjugate is 2. In fact, if I give you any purely complex any purely real complex number, if I give you any purely real complex number and ask you to find its conjugate, simply the conjugate will be the same. Get it or not? Because the imaginary part is not there. Okay. Now
Yes, sir.
suppose I give you another complex number z5, which is 3i, and I want you to find its conjugate. Come on, give me a quick answer. Yes? Come on! Out with it. Nobody? Hello?
Yes, sir.
What is the answer? What is the conjugate of 3i? Sital?
So 3i.
Okay.
How? How?
minus 3.
It will be minus 3i. How? Think about it. While you are trying to find the conjugate, we do not touch the real part. Its real part is 0. So forget about the real part. Forget about the real part. But we just do what? Reverse the sign of the imaginary part. And what is the imaginary part in this complex number? 3.
So 3.
We make
So
it
sorry,
minus
sir.
3.
This is minus 3i.
Make it minus 3i. Get it? Okay.
Yes, sir.
Similarly, if I give you another complex number, z6 minus 4i, what will be its conjugate?
So only 4i.
4i. it doesn't have any real part to talk about, doesn't have any real part, so forget about the real part. We don't care about the real part while trying to find the conjugate. All we care about is changing the sign of the imaginary part, and here the imaginary part is -4. We just change its sign, we make it +4, so it is 4i. So I hope you get it. Take the screenshot. Take it. Done. Take it. Done.
Done.
Yes, sir.
Okay. So if you do not if you do not interact in my class, I will simply do what? Remove you from the meeting. That I will do. Simply I will do that. If you from now on, whenever I am asking a question, wrong answer or correct answer doesn't matter. If you give wrong answer or you give correct answer, it doesn't matter. At least you have to give me answer. Okay. At least you have to give me an answer. Get my point so far? Everybody. I am talking about everybody. If anybody remains entirely silent throughout the class, I will simply remove him from the meeting. Am I making myself clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now let's find a modulus of some complex numbers. Now you remember, if z is a complex number, in standard form it is given as a plus ib. Then just like we find a modulus of real numbers, we can also find modulus of complex numbers. But in this case, in a complex number, there is a formula to find a modulus of the complex number, that is square root of
Root
square of
over of a square plus b square.
a square plus b square, where a is what? The real part of that complex number under consideration. B is what? The imaginary part of that complex number under consideration. So if I ask you to find the modulus of a complex number, what do? You take the square root of the sum of the squares of the real part and the imaginary part. You get my point? Real part, imaginary part. Take their square, take their sum, then find square root. Get my point so far?
Yes,
Yes,
sir.
sir.
And what else I told? Yes, and what else I told you? That this is a non-negative real number. I told you this, that the modulus of a complex number is a real number. It is a real number. Okay? and in addition to that, it is a non-negative real number. Modulus of any complex number cannot be negative. Modulus of a complex number cannot be negative. It is always either 0 or positive. Remember, by the word non-negative, I am not talking about positive. Non-negative means not negative. So it could be 0 or positive, because 0 is neither negative nor positive. So remember, non-negative means not negative. It could be 0 or it could be positive. Get my point so far?
Yes, sir.
Okay.
Yes, sir.
So suppose I give you a complex number. Let's say I give you a complex number z is equal to 1 plus 2i and ask you to find its modulus. So how do we find its modulus? By taking the square root of the sum of the squares of the real part and imaginary part. Well, what is the real part here? 1. So real part
So
square
1
plus imaginary part
plus b
square
square. The root over.
over. So 4 plus 1, 5, root 5. You
Equal
get
to
it?
root 5. Yes, sir.
Now guys, remember I told you that this symbol gives us only the non-negative square root. The non-negative square root. That is to say, suppose I want to find this. I want to find the value of this. Well, 4 has 2 square roots. We know that 4 has 2 square roots. One of them is 2, the other one is -2. Square of 2 is 4, square of -2 is 4. But what will the answer be here? The answer will be only 2 here.
So only 2.
Because you have just written this symbol, and this symbol only gives the non-negative square root. So between these two square roots of 4, which one is non-negative? 2. So it will give you 2 as answer. Now when will it give you -2 as answer? If you put a minus sign in front of it, then it will give you a -2. That is why when somebody asks us to find the square roots of 4, how do we write it? Let x square is equal to 4. If square of x is 4, then we say that what? X is a square root of 4, right? X is square root of 4. Because square of x is 4, that means x is square root of 4. So we write what? X is equal to plus or minus root over of 4. So one is for plus root over of 4, the other one is for minus root over of 4. And we know that before any number there is no need to put any plus. Okay, that's it. So you see, this will give you the answer 2 and this will give you the answer minus 2. You get my point?
Yes, sir.
Okay.
Yes, sir.
Very good. Suppose I give you a complex number z is equal to minus 3 plus 4i and I ask you to find its modulus. So what? Square of real part, what is the real part here? Minus 3.
So minus 3.
Square of real part plus square of imaginary part. What is the imaginary part here? 4.
So 4.
Then take the square root. Okay. So square of minus 3 is 9. Square of 4 is 16. This is a root over of 25. And like I told you, answer is what? 5. Do not write your plus or, do not write your plus or minus 5 or minus 5 or anything. Let me tell you, this symbol only gives us non-negative square root 5. And also you know that modulus of a complex number gives us what? A non-negative real number. It cannot be negative. You get it?
Yes, sir.
Yes, sir.
Okay. Now let's talk about, suppose I give you another complex number z is equal to 1. Well, what kind of a complex number is it? It's called a purely real complex number, right? Its imaginary part is 0. We know that every real number is also a purely real complex number, right? So it is a complex number. What is its imaginary part? Its imaginary part is 0, right? What is imaginary part? Imaginary part is 0.
So 0.
So let's just find its modulus. Let's just find its modulus. What will modulus be? Well, real part square. What is the real part here? 1. Plus imaginary part square. What is the imaginary part? 0.
So 0.
1 square is 1 plus 0 square is 0. 1 plus 0 is 1. Square root of 1 is what? 1. It will give you only the non-negative answer. Don't say that square root of 1 is plus or minus 1. I will write here. No. Only the non-negative square root. Okay? The non-negative square root of 1. I know that 1 has 2 square roots. One is plus 1, another is minus 1. But you will only write what? The non-negative square root. Get my point so far?
Yes, sir.
Yes, sir.
Now let's just think about it. Suppose I give you a complex number minus 1. Well, definitely it is also a complex number. It is a purely real one, right? A purely real complex number. And I want you to find its modulus. Well, let's just find it out. Then I will tell you a rule. Well, real part. What is this real part? Minus 1.
Minus
Real
1.
part square. Plus imaginary part square. Imaginary part is 0. Minus 1 square is 1. 0 square is 0. 1 plus 0, 1. Square root of 1 is 1. You get it?
Yes, sir.
Yes, sir.
So you can see one thing here. You can see one thing here, that modulus of both the complex numbers are the same one, right? Modulus of this is 1. Modulus of minus 1 is also 1. See here, right? So from this, I can just make a simple rule. Suppose I give you a real number. Suppose I give you a purely real complex number, let's say 3, and I ask you to find its modulus. Simply do what? Simply just treat it like a real number. Treat it like a real number. Find its modulus. Well, what is the mod of 3? If it was a real number, if you are talking about real numbers. Suppose if somebody comes along and asks you what the mod of 3, if you are discussing only real numbers, it is what? 3. So mod of z is 3. Get my point so far?
Yes, sir.
Suppose somebody
Yes,
gives you
sir.
the complex number minus 3 and asks you to find its modulus. Well, just find it. Simply find its modulus. Simply find its mod. What is the mod of minus 3? Same 3.
So
You
3.
get it? So this is the rule.
Yes, I got it.
This is the rule. Now the second rule, suppose I give you a purely imaginary complex number. Suppose I give you a purely imaginary complex number, say 2i. Well, 2i is a purely imaginary complex number, and I want you to find its modulus. Well, rule is what? Square of the real part. And as it is a purely imaginary complex number, can anybody venture to tell me what the real part of this complex number is?
Sir, 0.
0. Its real part is 0. So real part square means 0 square plus imaginary part. What's the imaginary part here? 2.
Sir, 2.
Well, the square of 0 is 0, square of 2 is 4, 0 plus 4 is 4, and the square root of 4,
Equal
well,
to 2.
equal to 2. It will give you a non-negative, it will give you the non-negative square root of 4, okay, 2. So modulus of 2i is what? 2, okay, keep in mind, okay, keep in mind. Now let's find a modulus of minus 2i. Square root of real part is what? 0, square of real part, 0 square. What is the imaginary part here? Minus 2.
The minus 2.
Okay. Now you see here that this is 0, this is 4, 0 plus 4, 4, square root of 4 is 2. Well, do you see something here? You see something here, that modulus of 2i, modulus of minus 2i, both are same as 2, right? So from here,
Yes,
you can try to understand the rule that if I give you any purely imaginary complex number, this is a purely imaginary complex number, it doesn't have its real part, the real part is 0. In this case, if I ask you to find its modulus, what you do? You simply take the mod of the imaginary part, just like it is a real number. What is the imaginary part here? B. Just take its
B.
mod. Just like you take mod of real numbers. Remember?
Yes, sir.
Just like if I ask you to find the modulus of minus 2i, what is this real part? Minus 2, right? So simply take the mod of minus 2. You get it?
Yes, sir.
Okay. So, 1 second, yeah. Take the screenshot. 1 second. Quick. Take it. Done.
Done, sir.
Okay. Take it. Done. Okay. Take it. Quick. Done. Okay. Take it. Done.
Done, sir.
Okay. Take it. Done. Okay.
Done, sir.
Okay, let's take another important observation here. Well, so far we have learned how to find the conjugate of a complex number, how to find the modulus of a complex number, and let's just make an important observation here. Okay. Suppose I give you, I want you to find, suppose there is a complex number z, let z is equal to a plus I. It's a complex number. Its real part is a and imaginary part is b. Well, if I ask you what its conjugate is, what is it? A minus ib?
Sir, A
You
minus IB.
You simply have to reverse the sign of the imaginary part. Here the imaginary part is plus b, you make it minus b. Okay, that's it. Now, what is the additive inverse of z? Additive inverse of z is minus z. Remember, in the last class we discussed additive inverse
Yes,
z
sir.
is minus z. Well, what is additive inverse? Simply multiply minus with it. Minus a minus ib. You get my point so far?
Yes, sir.
Yes, sir.
Okay, let's just do what? Let's just one by one find their modulus. Let's just find the modulus of z. Well, modulus of z is what? Square of its real part plus square of its imaginary part, then and whole square root. So a square plus b square root over, this is the modulus of z. Let's find modulus of its conjugate. Well, square root of square of the real part. What is the real part? Sorry, square of the real part. What is the real part here? A square.
Sir, A square.
Plus square of the imaginary part. What is the imaginary part here?
Sir, minus B square.
Minus b whole square. Don't say minus b square. Say minus b whole square. Otherwise, somebody will understand this. You are talking about this. No. These and these are not the same. You know it, right? This means
Yes, sir.
minus into b square. This means square of minus b. Okay, this means minus into b square. This is square of minus b. Okay. Now guys, you tell me, isn't square of minus b is the same as square of b? Because square of minus
Yes,
is
sir.
plus, square of minus is plus, minus into minus, minus b into minus b, isn't it b square? Direct, minus minus plus.
Yes, sir.
Okay. So do you see something here? That modulus of a complex number and its modulus of its conjugate, they are the same. Same. You get it?
Yes, sir.
Yes, sir.
Let's find the modulus of the additive inverse. Square of the real part minus a plus square of the imaginary part minus b root over a square plus b square root over minus a square is a square minus b square is b square. Do you see that modulus of minus z is the same as modulus of z? You get it? So
Yes,
from here we made an observation that modulus of any complex number is the same as the modulus of its conjugate is the same as the modulus of its additive inverse. In fact, see, obviously modulus of a complex number is the same as modulus of its additive inverse. Z conjugate is also a complex number. Z conjugate of a complex number is also a complex number. Conjugate of a complex number is also a complex number. So modulus of this complex number must be equal to modulus of its additive inverse, right? That means what is the additive inverse of conjugate of Z? Minus conjugate of Z, right? So it must be equal to that.
Yes, sir.
You get my point so far? So these four are equal.
Yes, sir.
So take the screenshot. Done. Done.
Done, sir.
Okay. So guys, can I say that directly without finding the value? Can I directly say that 3 plus 4i modulus must be equal to modulus of 3 minus 4i, must be equal to modulus of minus 3 minus 4i, must be equal to modulus of minus 3 plus 4i? Can I?
Yes, sir.
Can I? This is the complex number. This is its conjugate. This is additive inverse. This is the additive inverse of the conjugate. Additive inverse of the conjugate. What is the additive inverse of the conjugate here? The conjugate is 3 minus 4i. What is additive inverse? Minus 3 plus 4i, isn't it?
Minus 3 plus 4. Yes,
So
sir.
all of them have the same modulus. Okay. So take the screenshot. Done.
Done, sir.
Okay. Acha, one thing I noticed that I think I know it, that applied mathematics, only those students who had opted for basic maths, basic maths in 10th standard, right? In 10th matriculation exam, only those they can opt for applied mathematics, or what? I mean, all of you had opted for basic maths, or any of you had also standard maths?
Sir,
Huh?
I have taken standard math in both.
You have taken both standard maths and applied mathematics.
No,
Sir,
sir.
I have also taken.
Okay. In 10th you had taken standard mathematics, right?
Yes, sir.
Okay, but now you opted for applied mathematics. Must be the reason that you are not very good at mathematics, right? That must be the reason, or what?
No, sir.
Then why
Yes, sir.
why applied mathematics? Why not regular mathematics? What is the reason? Well, if you are taking an optional, then there must be some, you must be thinking about it, first. Otherwise, just randomly don't choose any subject. Because you like applied mathematics, or you are very good at applied mathematics, or you are not good at regular mathematics, or what? Hello.
Yes, sir.
Okay.
Yes,
What?
sir.
Okay. Where is Biswajit Pradhan? Biswajit Pradhan has left. How long ago he left? Okay. Okay. Now let's. Okay. Now, do you remember we have also discussed this in the last class, that a plus ib into a minus ib is equal to a square plus b square. We have discussed in the last class. This is there on the video, right? Are you right or not?
Yes, sir.
Okay.
Yes, sir.
And also we have proven. Well, what is this? This is z. What is this? It's conjugate. Z into Z conjugate. Z into Z conjugate is equal to, what is this? Isn't this square of mod of Z? Because what is mod of Z? Root over of a square plus b square. What is this square? What is square of mod Z? Just take out the square root sign. You get it? Hello. Yes.
sir.
So you have to keep in mind. Okay. So take the screenshot. Done. Done. Okay. To how to find multiplicative inverse. I am writing mi. Mi means multiplicative inverse, not mi of वो जो होता है गेमिंग में कौन होता है. Mi means multiplicative inverse or reciprocal of Z. I give you a complex number and ask you to find its multiplicative inverse or its reciprocal. How do you do it? Let's see. Do you remember I told you that there is a complex number 0? 0 is also a complex number, right? 0 is also a complex number. It's both purely real and purely imaginary complex number. In the last class we discussed, if you remember correctly. Do you remember I told you that that multiplicative inverse of 0 does not exist?
Yes, sir. It is not defined.
Yes,
Told
sir.
you.
Undefined.
Reciprocal of, because 1 by 0 is undefined. Okay. Other than 0, I told you, other than 0, any complex number, it has a multiplicative inverse. Only 0 is the only complex number which does not have a multiplicative inverse, because the multiplicative inverse is undefined. Other than 0, any complex number I take, it has a reciprocal or it has a multiplicative inverse. And also, reciprocal of a complex number is also a complex number. Reciprocal of a complex number is also a complex number. If I take reciprocal of a complex number, I will get another complex number. You get my point so far? So let's just learn to find the reciprocal of a complex number. Suppose I give you a complex number z is equal to 1 plus 2i, and I want you to find its reciprocal. Well, reciprocal means I want you to find 1 by z. Reciprocal or multiplicative inverse of z means 1 by z. 1 by z means what? 1 by 1 plus 2i.
1 plus 2i.
Well, let me tell you one thing. I just told you that reciprocal of a complex number is also a complex number. That means this one is also a complex number. 1 by z is also a complex. This is a complex number. But there is a problem. There is one problem. This is a complex number. That's right. I am not denying it. Of course, it is a complex number. But there is one problem. It is not in its standard form. It is not in its standard form. this thing is a complex number, but it is not in its standard form. Because in standard form, how do we write a complex number? A plus IB. This is how we write a complex number. Some real number plus I into another real number. This is the way we represent a complex number in its standard form. So even though this ratio, it is a complex number, still it is not in its standard form. So our target is what? To bring it to its standard form. We can't just leave it like this. We have to bring it to its standard form. Okay? Now let's bring it to standard form. Now see, in order to bring this to standard form, our first target is to get rid of this I thing on the denominator. Let me rephrase. In order to find the multiplicative inverse of this complex number, in order to bring it to standard form, first thing, I have to get rid of this I somehow. This I is causing all the problem. On the denominator. No I should be there on the denominator. So how do I do that? I will simply do what? I will multiply the conjugate of the denominator. What is the conjugate of 1 plus 2i? 1 minus 2i, right?
So 1 minus 2i.
Okay. Now you see, if you multiply something on the denominator, you also have to multiply the same thing on the numerator. Otherwise, the fraction will change, right? If I multiply 1 minus 2i just on the denominator and keep the numerator 1 as it is, then it will be a different number, not the same number, right? So I have to multiply 1 minus 2i both on the numerator and denominator. I have to multiply the conjugate of the denominator on top and bottom both. Well, why did I do that? By doing so, I will be able to get rid of I. How you see? What is 1 plus 2i into 1 minus 2i? Well, here you have two choices. Let me tell you. 1 plus 2i into 1 minus 2i, how you will calculate? One, I have already given you the formula a plus ib into a minus ib is equal to a square plus b square. I have given you the direct formula. So by applying direct formula, you can see that a plus ib into a minus ib is equal to a square plus b square. 1 square plus 2 square. Get it? Direct.
Yes, sir.
Otherwise, there is another way to go. What you can do, just like you can just prove it. Like this is your x, this is your I, x plus y, x minus y. X plus y into x minus y is equal to x square minus y square. Means a square minus square of ib. Well, a square is a square minus I square is what? Minus 1 and then b square. Well, minus plus, a square plus b square. So in this, applying this logic also, you can find it here. Consider this x, consider this y, x, y. X plus y into x minus y is what? X square minus 1 y square. So 1 square minus 2y square. Well, 1 square is 1, minus 2 square is 4, I square is minus 1. So 1 plus 4 or 5. You can see here 1 square plus 2 square is 5. So there are two ways to do it. Okay, it's up to you whichever way you opt for. Get my point so far? Hello.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Do you see that by doing so, I have gotten rid of I on the denominator? Now there is no I on the denominator, right? Got it? That was our target. Okay, have we made any changes to the complex number? Have we made any changes to the value of the complex number? Guys, give me 1 second. Okay. So, okay, now tell me, have we made any changes to the complex number? No, of course not. I haven't made any changes to the value of the complex number. Because I did what? I multiplied 1 minus 2i on the denominator, but also I multiplied it on the numerator. I didn't just multiply it, I also multiplied it on the numerator. These two will cancel out and you will get the same thing. Value has not changed. Value of this is the same as this. That's why I am putting equal here. Also, here also I haven't changed any value. 1 plus 2i into 1 minus 2i justifiably is equal to 1 square plus 2 square. On the numerator is 1 minus 2. I haven't made any changes to the value. But yes, I am making a change. What kind of change is that? I am just changing its form. I am just changing how it looks. You get my point? You get it?
Yes, sir.
Ah.
Yes, sir.
For example, 4 is also equal to 8 by 2. They have the same value. They are the same numbers. But they just look different, right? They just what? Look different. Similarly, here I am doing what? Keeping the value same, I am just bringing it to look in its standard form. Okay, so check it out. What I am doing. So 1 minus 2i divided by this is what? 5. Can I write it as 1 by 5 minus 2 by 5i? Hello.
Yes,
You
sir.
got
Yes,
it.
Yes, sir.
Yes, sir.
Bas. Now it's in its standard form or not? 1 by 5
Yes,
plus
sir.
minus 2 by 5i.
Yes, sir.
It is in standard form? Yes.
Yes, sir.
So this complex number and this complex number, they are the same complex number. We haven't made any changes to the value. We simply just changed how it looks. Okay, we brought it to its standard form. That's it. Just like when you go to market wearing makeup, then when you come back, when you remove your makeup, do you become a different person? No, you are the same person, just you will look different. Get my point so far?
Yes, sir.
Yes, sir.
Yes. Similarly here, we are just putting on some makeup to this complex number and made it look like this. Otherwise, they are the same complex number. Okay, equal. I got it. Take the screenshot. Done. Hello, done.
सर ये वाला कॉन्सेप्ट सबको क्लियर हो
Done,
गया
sir.
होगा.
Yes. So using this logic, you can now find reciprocal of any complex number. Well, there is one complex number whose reciprocal is not very difficult to find, which is, suppose I give you reciprocal of I. While finding reciprocal of I is also a complex number. It is a purely imaginary complex number. If I want to find its reciprocal, means 1 by I don't have to go into all that trouble. I will simply do what? I will just multiply one I on the numerator and I on the denominator. That's it. So I by I square is minus 1. So it is what? Minus I. Remember? It is now in its standard form. Minus I is in standard form or
Yes,
not?
sir.
0 minus I.
Yes, sir.
Yes, sir.
Yes, very good. Now you can find reciprocal of any complex number, hopefully, right? Okay. Now
Yes, sir.
let's talk about a theorem. The theorem is reciprocal of a complex number. If z is a complex number, and it's not equal to 0, because 0 doesn't have any reciprocal. If z is any non-zero complex number, then if I want to find its reciprocal, there is a direct formula also. Conjugate of z by modulus of z square. I will tell you how this formula, where did this formula come from. Just there is 1 by z. We want to find the value of 1 by z, right? We want to bring it to standard form. Okay. Now guys, if I multiply the same thing on the numerator and denominator, does the complex number change?
No, sir.
No, right? So I am going to do what? I am going to multiply the conjugate of the denominator. What is the conjugate of z? Z conjugate, like this, okay?
So,
On the
Jacob.
denominator and also on the numerator. Otherwise value will change. By doing so, on the numerator I have now conjugate of z. On the denominator, well, we have already learned that z into z conjugate is equal to z mod square, right?
Yes, sir. Z
Yes, sir.
mod square.
So that is how this formula is derived. Take the screenshot. Done. Okay.
Done, sir.
Okay, very good. So suppose I want you to find the reciprocal. So this is directly you can apply the formula and find the reciprocal. Find the reciprocal of z is equal to 1 minus 2i. Suppose I ask you to find reciprocal of 1 minus 2i. You know that reciprocal of z is what? 1 by z. 1 by z means formula is z conjugate by mod of z square. I mean square of mod z, right? Direct formula. Or you can also do 1 by 1 minus 2i, then you can multiply 1 minus 1 conjugate of the denominator on the top and the bottom, then you will do all that and you will get the correct answer, just like we did. But here you are going to apply direct formula. What is z conjugate? If z is 1 minus 2i, what is conjugate?
So
Plus
1
2i.
plus 2i.
What is this modulus? What is this modulus? Root over of real part square. Real part is 1 plus imaginary part minus 2 square. I got it.
Yes,
Sir.
Now what is square of mod z? Root 5 square is what? 5. So simply directly I will write conjugate of z, which is 1 plus 2i divided by mod z square is 5. So directly I am going to write 1 by 5 plus 2 by 5 into I. You got it? So directly
Yes, sir. Got it.
the same thing that we did, but just applied the direct formula. Okay, the same thing that we did. The formula is derived in the same way. Okay, the way that we have found the reciprocal of the complex number in the previous question. Okay, in the same way this formula has been derived already. So just apply the formula. Get my points पर कर पाओगे? Take the screenshot. Done. Hello, done. Okay.
Yes, sir.
Now let's just quickly
Yes,
learn.
sir.
Let's just quickly learn a division of two complex numbers. Or division between two complex numbers. If Z1 and Z2 are two complex numbers, such that Z2 is not equal to 0, then Z1 divided by Z2 is also another complex number. Now if Z1 and Z2 are two complex numbers and Z2 is not equal to 0, then Z1 divided by Z2 is also another complex number. So by dividing one complex number by another complex number, another non-zero complex number, you also get another complex number. You get my point?
Another complex number.
Complex number divided complex number is complex number. But why did I write Z2 must not be equal to 0? Because if Z2 is equal to 0, if denominator is 0,
It will be not win. It will be converted into not defined.
it is not defined, right? So Z2 must not be equal to 0. Okay, otherwise Z1 can be equal to 0, it's fine, but Z2 can.
So integers जैसा terms of condition हो गया.
Yes. Everybody now got it?
Yes,
Yes,
sir.
sir.
Very good. Now I am going to give you a direct formula. You see, Z1 by Z2, isn't it equal to Z1 into 1 by Z2?
Yes, sir.
Z1
Yes, sir.
into, well, 1 by Z2 means what? Reciprocal of multiplicative inverse of Z2. We just derived this formula. Conjugate of Z2 by square of the modulus of Z2. You remember?
Yes, sir.
Remember? What
Yes,
about the
sir.
others?
Yes, sir.
Very good. So I will divide one complex number by another complex number in the traditional way, then also using the formula. Suppose Z1 is equal to 1 plus 2i and Z2 is equal to 3 plus 4i, and I want to find Z1 by Z2. Well, just find it out in traditional way. Z1 by Z2. Z1 is what? 1 plus 2i by Z2 is what? 3 plus 4i. Now guys, you tell me one thing. Didn't I just tell you that one complex number divided by another non-zero complex number is also another complex number? I told you, right? This is a complex number. You can see this is a
Yes,
complex
sir.
number. But there is a small problem. Even though this is a complex number, that's for granted, it is a complex number, but it is not in its standard form currently. It is not in its standard form. So we have to bring it to a standard form. We have to do what? Bring it to a standard form. Now you see, while we are trying to bring it into a standard form, our first target must be to somehow get rid of this I on the denominator. There should not be any I on the denominator. That should be our first target. So what I am going to do to get rid of I from the denominator, I shall multiply the conjugate of the denominator on the top and on the bottom. Obviously we have to multiply it both on the top and the bottom, otherwise the value will change. We are just trying to change its looks, not its value. Value must remain the same. So numerator there was 1 plus 2i, we will multiply it to 3 minus 4i. Okay, what is the
3
conjugate?
minus 4i.
Okay, very good. Now on the denominator, directly if you remember, a plus ib into a minus ib is equal to a square plus b square. Then this is 3 square plus 4 square.
So 3 square plus 4 square.
Bas. On the numerator, 1 into 3, 3 minus 4i plus 6i minus 8i square. Get it? Hello. 2i into minus.
Yes, sir.
Yes, sir.
Very good, very good. So this is what? 3. 6i minus 4i is what? 2i. Well, I square is what? Minus 1. So minus 8 into
So minus
minus
1.
1, it becomes what? Plus 8. It becomes what? Plus 8. Let's
Yes,
just bring
sir.
the real numbers together. 3 plus 8. Bring the real numbers together. Bring the then this is what? 3 square plus 4 square is what? What is it? What is it? Tell me. What is? Yes. 3 square plus 4 square is what? 16 plus
25.
9, 25. Very good. Okay. Bas. So this is what? 11 plus 2i upon 25. So what? 11 upon 25 plus 2 upon
So
25.
2 by 25 into I.
Yes. I didn't change its value. The value is as it is. The value is as it is. I just changed its looks. How it looks. Got my point? Otherwise, I just
Yes, sir.
I just brought it to a standard form.
Yes, sir.
So take the screenshot. Done. Okay.
Yes.
Done, sir.
Okay. Take it. Done. Okay.
Done, sir.
So I am just
Yes, sir.
okay. I am just giving you some questions. Just write them down, and you will do that. Do those questions. Practice those questions, huh? Okay. Write it down. These questions from complex number. You write them down. Write down 1 plus I square plus I cube is what? घर में करोगे, okay? Hello, get it?
Yes,
Okay,
sir.
Okay, sir.
So
I to the power 5 plus I to the power 6 plus I to the power 7 plus I to the power 8 करोगे. I to the power minus 98 का वैल्यू निकालोगे. I to the power 204 का वैल्यू निकालोगे. रूट ओवर ऑफ -2 इसका पावर 5 निकालोगे. हाँ ओके, मैं करता हूँ आपके लिए, आसान करता हूँ, 4 करता हूँ इसको. सही से निकालोगे भाई, सोच के. इतना इजी नहीं है जितना इजी समझते हो. पहले फॉर्मूला याद करोगे, जो नोट में लिखे हो उसको पढ़ोगे, फिर जाके करोगे. डोंट डू डायरेक्टली, यू विल मेक मिस्टेक्स, लॉट्स ऑफ मिस्टेक्स यू विल मेक. Okay, this is not an ordinary square root of 4. This is square root of -4. Its answer is an imaginary number. It is not a real number. Square root of a negative number is not a real number. Remember all that, right? Okay. Then you will find I to the power 10 plus I to the power 12 plus I to the power 13. Okay. Then you will find if Z1 is equal to 1 minus 2i, नहीं, Z1 equal to 1 minus 2i, find conjugate of Z1. You got it?
Yes,
If
sir.
Yes, sir.
if Z2 is equal to -3 minus 4i, find mod of Z2. But Sunday there will be a class in the afternoon. Okay. Sunday we shall have a class in the afternoon from. I will tell you. Okay, I will tell you in the group. I will inform in the group. If not Sunday,
Okay,
then we'll take the class on Monday. But someday we'll take an extra class. Okay. So you will find this. Then you will find 2 plus 3i into 4 minus 7i. Then you will find 1 minus 3i divided by 4 plus 7i. Then you will find multiplicative inverse of, अरे mi मतलब multiplicative inverse है, keep in mind, of z is equal to -1 minus 2i. You get it? Hello.
Yes, sir.
yes, sir.
Yes, sir.
Okay. Then
Yes, sir.
find if z1 is equal to 1 minus 3i, z2 is equal to 1 plus 3i. Find z1 plus z2. Find z1 minus z2. Find z1 into z2. z1 into z2. चलो लगे हाथ. Find z1 by z2 also. क्यों छोड़ दें उसको, नहीं. Okay, so this is the assignment that you will do, and if any doubts you will ask me in the next class. Get my point so far? Take the screenshot.
Okay, sir.
Take the screenshot.
Done, sir.
Done. Thank you guys. Thank you very much. You can leave now. Bye.